Hello students, welcome back to the physics class again, and I am here to discuss on the electricity as we are discussing on the current electricity. As a part of the electricity, we will discuss the electric potential and potential difference, symbols used in the circuit diagram, Ohm's law, resistance and resistivity, conductance and conductivity. So we already know the electric current. So it is the flow of the charges. The electrons flow from negative terminal to the positive terminal of a cell across the conductor. And it is also well known fact that the electrons in atomic particle carrying a negative electric charge, electrons exist in all atoms and can be detached from the atoms of certain elements quite easily. And that means some of the electrons can be removed from the valence electron by supplying certain small amount of energy. These are known as the free electrons. It is one of the fundamental results of the electrostatics that the electric field within a conductor placed in electrostatic field is zero. That means the electric field inside a conductor is zero. This happens because the free charges within the conductors redistribute themselves under the influence of the applied field so as to make the field within the conductor everywhere zero. The motion of the charges then stops, and we now know that the conductor is connected to something which supply or absorb the charge as required to maintain the original field, and this maintained field will act on the free electrons in the conductor and will give them a resultant motion in the direction opposite to that of the field. So charges in the motion constitute an electric current, and this motion of the current at any is possible in a conductor when we are maintaining then means when we provide a potential difference across the conductors. That means it follows that means any source which can produce such a force which provide a constant current in a conductor is called electromotive force. The electric force due to the chemical reaction may be due to the thermocouple that can produce the constant flow of the current in the conductor. So what is the electric potential? The electric potential is a physical quantity which determines the flow of the charges from one body to another, and it is a physical quantity that determines the degree of electrification of a body. So electric potential at a point in the electric field is defined as the work done in moving a unit positive charge from infinity to that point against the electrostatic force irrespective of the path followed. So that means it does not depend upon the length of the path. It depends upon only between 2 points, the initial and final points. So such type of the force as we have discussed is called conservative force. So the work, therefore, the work done by charge will be defined as the potential difference or electric potential, V equal to W by Q. And SI unit of electric potential is volt or joule per coulomb or Newton meter per coulomb. So it was named after the Alessandro Volta, an Italian physicist. Then what is the 1 volt? 1 volt electric potential is if 1 joule of work is done by a 1 coulomb of charge in moving it from infinity to that point in the electric field. That means when we bring a 1 coulomb of charge from infinity to a point in within the electric field of a charged particle, then the amount of work done per unit charge will be called 1 volt. So let's see an analogy of electric potential difference. Here we have two cylinders A and B of different radii. That means they are of different radius. Their radius are different, but their waters contained are also different. The water level in A is higher than the water level in the B, but the amount of water present in the A is less than the amount of water present in the B. So cylinder A is connected to another cylinder B through a stopcock, and the quantity of water in A is less than the quantity in B, but the level of water is higher in A than B. When the stopcock is open, this water begins to flow from A to B till the levels are levels are, or level in both A and B are the same or equal. So when this happens, there will be no flow of water. So from here we can conclude that, or we can observe that it is not the quantity of water but the level of water which decides the direction of flow of the water. And here the water in A is at higher gravitational potential and the water in the B is at a lower potential. That means the level of water in A is higher than the level of water in the B. So that difference is known as the gravitational potential, and it is the gravitational potential difference that is responsible for the flow of water. Similarly, electrons move only if there is a difference in electric pressure, and electric pressure is called electric potential difference along the conductor. So the flow of electricity in current electricity has electrical pressure or voltage, and electric pressures flow from an area of high voltage to an area of low voltage, similar to the water flow from higher level to lower level. Therefore, the charges flow from higher concentration towards a lower concentration, that means high voltage to low voltage. The water pressure and the voltage behave in the similar ways. Then what is the electric potential difference? The electric potential difference between any 2 points in electric field is defined as the work done in moving a unit positive charge from one point to another against the electrostatic force irrespective of the path followed. Therefore, we can define the potential difference. Here it is denoted by VA, BV minus VA, or delta V, and work done by the charge. Work done to bring a charge from A to B divided by charge Q. So the electric potential and potential difference are scalar quantities, and electric potential at infinity is supposed to be 0, and electric potential near a isolated positive charge is positive, and that near a isolated negative charge is negative. That means electric potential produced by positive charge is positive, and electric potential produced by negative charge is negative. And the CGS unit of electric potential is volt. Here are some symbols that we use in drawing a circuit diagram. So these are the symbols used in the circuit diagrams. So just look at the circuit diagrams. Representation of circuit diagram in different symbols has been given, like electric cell, battery, plug key or switch open, plug key or switch close, wire joint, wires crossing without joint, electric bulb, resistor, resistance, variable resistor or rheostat, ammeter and voltmeter. Now coming to the flow of the current, and it is given by a law known as Ohm's law. Then what basically is the Ohm's law? Ohm's law is one of the best known formulae in physics, which relate the current flowing in a conductor with a potential difference at its ends. As we have seen, the current is nothing but the flow of the charges, and the charges will move in the conductor only if some forces pushes them, and that forces we call it electromotive force. And the application of potential difference establishes the electric field in the conductor, and it is the force due to this electric field that pushes the charges along. But if this force is continuously acting on the charges, then why is it that the charges are not continuously accelerated? A continuous acceleration of the charges would imply that the current should keep on increasing with the time. In practice, however, only a steady current governed by Ohm's law flows. So what is the Ohm's law then? Ohm's law states that the current flowing through the conductor under constant physical condition is directly proportional to the potential difference across the two ends of the conductor when the physical conditions such as the temperature, mechanical strain, etc. remain the same. So this must be remembered that the current flowing in the conductor does not only depend upon the potential difference, it may also depend upon the external factors. So here the physical conditions means the external factors, such as like temperature, mechanical strain, the length, that means the straightness of the length, the bending of wire, the presence or absence of tension, or maybe the presence or absence of the magnetic or electric field around the conductor. So this is what we call the Ohm's law. I is directly proportional to V, or V is directly proportional to I, and we have a formula called V equal to IR. So when we apply the current of potential difference across a conductor, a current flows through a conductor, and that potential difference is directly proportional to the flow of the current. So Ohm's law experiment simply indicates that the B and I graph should be a straight line graph, because the equation that we got is B equal to IR, which is a linear equation. And it must also be remembered that Ohms carried out his experiment using the metallic conductor, and later experiments with a different material show that the Ohm's law is not always valid. That means Ohm's law cannot be applied everywhere in the conductor. The metallic conductors constitute a special case in that the current voltage graph for them through the origin are also linear over a wide range of the voltages. For several conductors such as like diodes or maybe thermistor, bulbs, semiconductors, the current voltage graph may not be linear, they are non-linear actually, and they do not obey the Ohm's law. So that means the Ohm's law also has its own limitations. Then what is the resistance? So from the Ohm's law we have V equal to IR, and there the R represents the resistance, and we have already learned that whereas some materials means the insulators could not allow the charges to pass through them. So in the quantitatively speaking, when the resistance of a material is there, the resistance is there, that means the flow of the charges is opposed by the property of the material, and that is why we call it resistance. The resistance of the conductor is the opposition offered by the conductor to the flow of the electric current through it. So from the graph we have R equal to VI. This is, we call it the resistance. And from the IV graph, the slope of the graph, the inclination, the angle made by the star line to its horizontal axis, tan theta, will give you the resistance. And there are some factors which on which the resistance of the conductor may depend upon, like the length, the area, and temperature. So here, if you maintain the temperature constant, then we got R is directly proportional to length and inversely proportional to the cross-sectional area, and here the rho represents the resistivity of the conductor. It is also called a specific resistance. Then resistance is directly proportional to the length and inversely proportional to the cross-sectional area of the conductor, and depends upon the nature of the materials also. So resistivity depends upon the nature of the material alone and not on the geometrical dimension of the conductor. Both the resistance and resistivity vary with temperature. Then the resistance is measured in terms of a unit called ohm, and it is denoted by the symbol omega. If the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 ampere, then the resistance of the conductor is said to be 1 ohm. That means that 1 ohm is defined as if a potential difference of 1 volt could be maintained between the ends of the conductor when the current through the conductor is 1 ampere, then the opposition offered, the resistance, is called the 1 ohm resistance. And the SI unit of resistivity is the ohm meter. Then when we take the reciprocal of the resistance and the conductivity, a new term is being come up, and that is known as the conductance and conductivity. The reciprocal of the resistance is called conductivity, and the reciprocal of the resistivity is called conductivity. The conductance is the reciprocal of resistance, is SI unit is mho, and the conductivity is the reciprocal of resistivity, and its SI unit is a mho per meter. So this is the end of today's lesson, and if you liked the video, hit the like button and leave some comments on the comment box. I will come up with a new video in the next session also.